In this episode, we will look on easy designing an RC plane and CNC milling of templates. RC plane can be built up with many techniques, like arming wing from Depron or foam board. In my case, it will be built from XPS foam and hot wire cutting to achieve perfect airfoils for aerodynamics. The main design criteria will apply for any technique you would choose. I want to try wire cutting as training before making this plane that I designed in the past. Well, designed. It's heavily inspired by Talon GT Rebel. I like that design a lot. Making my own Talon variant means I can customize anything to my needs. Side note, if you're not familiar with CAD programs, don't get scared. It's not crucial even for making the templates for hot wire cutting, as there are other ways to do so, as well as simple calculations for dimensions and wing loading. I use CAD software because it's what I do for a living. Plus it will be easier to show the design for video purposes. The design was inspired by RC FPV and his Silver Guardian. I loved the look for tractor configuration. I had the same 5010 motor with a big prop planned to be installed on my UAV pusher. But it would require a significant rebuild of motor mount, though I kept it for another project. So I came across Silver Guardian and the decision was made, with some changes though. Requirements: NACA Airfoil 4412 for the main wing and 0010 for the V-tail. Tail servos embedded in the airfoil to reduce drag. 3D printed tail assembly for easy mounting and modularity. Wingspan 1200 mm with polyhedral in one piece. Wing loading low to mid-range 25 to 50 grams per decimeter squared. All-up weight as low as possible. Flexible wing mount. Shorter carbon tail boom that doesn't go through most of the fuselage. And main focus on wire cutting the airfoils as entry-level opportunity to practice this technique. Therefore, fuselage will be made out of Depron as it's nothing so special. Let's have a look on the dimensions. Just a side note, of course there are many calculations and equations for a plane design, but for absolute simplicity we will use the easy bare minimum. If you want to make your own easy plane, there is really no need to go crazy with the calculations, so let's call it the lazy way. The main requirement is the wingspan of 1200 mm. From this value we will determine the other dimensions and requirements. Now we need to know the chord width of the airfoil. The aspect ratio aims between 5:1 and 7:1, and with range of wing loading between 25 to 50 grams per decimeter squared, which also asks for all-up weight requirements and wing cube loading. At this point I can't really tell how heavy the entire plane will be, with all the materials I use. I would focus on the maximum limit for wing loading and the maximum all-up weight. So for airfoil width, let's make examples for different aspect ratios. 5:1 gives me 240 mm, which is 28.8 decimeters squared of surface area, and 1440 grams maximum all-up weight with 50 grams of wing loading. Another examples as follows: 6:1, which is 200 mm, 24 decimeters squared, and 1200 grams. 5:1, which is 171 mm, 20.4 decimeters squared, and 1020 grams. I picked up the higher all-up weight configuration to have an extra room for heavier battery, or simply lower wing loading for the wing surface area. The length of the fuselage is referenced to general rule of 75% of the wingspan, therefore 900 mm. For V-tail I will use 35% of main wing surface area. For conventional tail the rule differs slightly, which falls between 25 to 30%. From this value we should get length and the width in correlation with desired aspect ratio. In summary, the aspect ratio of the horizontal stabilizer for an RC plane generally falls between 3:1 and 5:1. And since my V-tail is swept, I use it only as a rough reference, so I played with the tail dimensions until I got the desired 35% surface area. The main wing lays flat on the fuselage, that means it has inherently 3 degrees angle of incidence. The tail has -3 degrees relative to the main wing, so 0 degrees relative to the fuselage. The fuselage design is for reference only. It's the only part where design change and compromise is allowed, as the wings are the most important. Plus the weight distribution, which is crucial to get the CG right. At this point, it has enough space for 2 4S lithium-ion batteries, flight controller and other equipment to make it UAV, even though I plan to fly this manually for my entertainment. Now let's have a look briefly how I made the airfoils and tail assembly in Fusion 360. I found my airfoil I like on the Airfoil Tools website and downloaded the data. You can also download the plot for printing on paper, so you can make your templates manually from plywood or so. In Fusion, using the Airfoil plugin, I imported the plot on Sketch and started extruding. Because I have Polyhedral, I will support the segments of the wing by bended square aluminum profile. And to keep it lightweight, I kept the middle part quite short. The aluminum profile will go to the outer part just few centimeters, where 8mm carbon spar continues, and it fits perfectly to the L profile. To make it a bit easier, I run a square channel through entire wing, so the L profile and carbon spar will be glued with foaming Gorilla Glue. And then to the tips, which are now just a prototype. I like this wing shape with the tips pointing down. So I will either cut them from short XPS segment, or I will print out a mold and cast with foam. The main wing will be on flexible mount, using rubber bands make it more crash proof. Also easy to transport and assemble. The wing mount assembly has 2 4mm carbon spars running through these cross members that will be glued to the fuselage. This rear bar is special as it also mounts the 12mm tail boom. It's combo of plywood and some light wood. Not that heavy actually, but it holds the boom very well. By the boom we continue to the tail assembly part, which will be 3D printed. This part has slots for the airfoils, which are intended to be glued in, reinforced with a carbon spar, and include servos, which I am quite happy they will fit inside. I have 2 variants, one with and one without this stabilizing fin, but more than stabilizing, it would be appreciated as a tail protection for belly landing. There could be a variant also for mounting FPV camera. And now to the templates. I simply projected the airfoil shape on extra sketch, added small holes for fixing the templates to XPS foam while cutting. Also these holes as drilling template to reinforce wing joints with short spars, and the same procedure for the tip and tail. I use an offset face feature to make my template 0.5mm bigger to compensate the heat from the hot wire. With the templates done, let's lay them down, arrange and make CNC program for milling. Milling 1-pass profile operation with 3mm 3 flutes, fresh and sharp end mill, low feed and high RPM. Plunge lead in and out. 1mm fixing holes. Run the simulation to make sure all good and begin with the very first manufacturing process. Now just enjoy the time-lapse footage. And here we go, nice sharp cut, precise templates for making nice and precise airfoils. That's it for this video. In the next episode I will assemble my easy DIY hot wire cutter and start with cutting out the airfoils. Thank you so much for watching, I hope you enjoyed this video. Let me know your thoughts in the comments, leave a like and I will appreciate if you will subscribe to my channel. Take care and I will see you next time.